Hey everyone. So I'm going to cover the inverse derivatives in this video. There are multiple inverse derivative problems in your sample assessment and in your in-class. However, I'm going to be very clear about what you actually need to be able to do for your for your summative so that you don't overstudy the wrong things. I would feel really bad if you guys do that. So these first two slides are going to cover what you need to know. Let me be very specific on that. You need to know how to do every inverse trig derivative with one term on the inside and plug it in to its derivative. So you basically need to just memorize all 6 of them and be able to just evaluate a derivative by plugging in that argument, like of negative 4x squared, which I will do in just a second. And then for the a little more general inverse derivatives, you need to be able to do problems that are very similar to what is in this slide. I'm going to cover the questions on some of these applications. However, on these 3 slides, which I will do in this video, you will not have to do applications involving inverse derivatives. I'm going to do them just in case you're interested, but I'm just going to be very clear because I don't want you to study the wrong stuff. Like this one right here is a product rule, 1D2. You won't have to do product rule with inverses, although it's not that hard, and I'll show you how to do it. Also, equations of tangent lines for any function should, in theory, always be fair game, but it already gets a little crazy just by memorizing the derivative of arc sine or inverse sine. So I will do those, but really, these first 2 slides cover everything you actually need to know for the summative. So let it be said. All right, so inverse cosine derivative. Here we go. U is negative 4x squared. So I'm going to plug it in to the derivative of arc cosine or inverse cosine formula. So negative 8x all over the square root of 1 minus u squared. Literally, that's just do the derivative, plug it in. Notice how the negative 8x in the numerator is the derivative of the inside. That's kind of like a chain rule idea. This right here would be 100% perfectly fine for free response. However, certainly for multiple choice, you would want to clean it up just a little bit. So let me just do that. That's going to be positive 8x because the negatives cancel, all over root 1 minus 16x to the 4th. This is a little bit nicer and 100% fair game for multiple choice. There you go. You know what? I'll even do another one. I'll do number 4 down here just so that you can see sort of another example. We have a constant. Constants aren't affected by derivatives. So let me just, I'm going to do the work up here. So f prime equals 5 times all of the cotangent stuff, which is right here. Your inside, or your u, is 2e to the x. The nice thing about this is that the derivative of 2e to the x is just 2 to e to the x. So I'm just going to write negative 2e to the x up there. E to the x is very, very nice. All over 1 plus 2e to the x squared. 2e to the x squared. That's it. We are totally done. I can clean it up. Might as well. So let me just rewrite that here. Let me multiply that 5 inside, negative 10 e to the x, all over 1 plus 2 squared is 4. E to the x squared, that's really e to the x times e to the x, which is actually e to the 2x, if we remember some Algebra 1 jaunt. And there we go. Now, the whole e to the 2x thing, like all that simplification, you would see that in a multiple choice. However, we know that free response, I will accept anything. I will accept the unsimplified version like this. But it's always nice to know how to simplify. Great. Let's keep going. I'm going to go on to these table-y problems. We have a table. It says g of x is the inverse of f. So basically, two functions are the inverses of each other. Let's remember that, well, actually, let me just start with this here. It says find g prime of 3. To find g prime of 3, which, by the way, we know this whole problem, if we have the derivative of the inverse, the whole entire problem is going to be 1 over f prime of something I'm about to find. The derivatives of inverses are reciprocals using a reflected point. I will come back to that very often with all these inverse problems. The derivative of inverses, reciprocals of reflected points. So what do I mean by that? It's asking for an x value of 3. So if the inverse has an x value of 3, f should have a y value of 3. Well, here it is. That means x had to have been 4 for the inverse. Really, this whole problem is saying to find g prime of 3, do 1 over f prime of 4. That's your entire answer. Let's do it. To find the derivative, evaluate at x equals 4. F prime of 4 equals... Oh, sorry. That is a little bit of a mistake there. 2. So, take the reciprocal of f prime of 4. G prime of 3 equals 1 over f prime of 4, which equals 1 over 2. That's it. This right here is all of the work you would need for this whole problem. It's just that this little 4 square kind of maps out all the steps, but in reality, when I am doing these problems, I only write that and I am done. I move on. These are wildly popular multiple choice problems on the actual AP test. So I really like these. Let's just do another. This is basically the same thing. Find g prime of 4. That's going to be equivalent to 1 over f prime of whatever 4 produces for us. So to reflect the point, find an x for y equals 4. So I need f of x equals 4. All right, so let's look for that. I'm going to come up here. If my y value needs to be 4, my x value must have been 2. Let me go back to my scratch work here. The whole problem is saying 1 over f prime of 2. That's the entire problem. So let's evaluate the derivative at 2 for f. F prime of 2 equals f prime of 2. So let me circle that right here. F prime of 2, 3. I don't know why I had that second line there. My bad. So g prime of 4 equals 1 over f prime of 2, which is 1 over 3. This is all the work I would have shown if I didn't have this nice little t-chart to show me. So there you go. That is how you do pretty much every inverse derivative problem. The only way it gets harder is if this table was not there to give you all the derivatives and y values and x values already. It is possible that you have a calculator problem where you have to, solve this instead and then do it kind of a little more by hand or, with a calculator. But this one kind of gave you all the x, y values and also the derivatives. But really, what I want you guys to remember is that to find inverse derivatives, reciprocal of the reflected points derivative. All right, so at this point, I have covered everything you need to know for the summative. I will move on though, in case you're interested. We have a product rule, 1, D2. This is not bad. This actually would be fair game. It's just It just doesn't happen to be on your summative. But let me just cover it. So 1, d2. But d2 is just one of these memorized derivatives. U prime over root 1 minus u squared. U prime over square root of 1 minus u squared. So that's 1d2 plus 2 d1, which is 1, because the derivative of x is 1. And that's it. That's it. It's right here. It's C. Okay, so that would be really easy. That's really not bad at all. But I admitted that this is not actually going to be on your summative, but there you go. Let's keep going. Tangent line. This is not bad either. Y minus y1 equals mx minus x1. Origin. That means this is 0. That is 0. This is not bad. Arc sine of this, y prime equals u prime. U prime is 1/2 x. Or no, sorry, that's u. I'm just rewriting that. So the derivative of 1/2 x is 1/2. U prime over square root of 1 minus x squared, or u squared, which is going to be x over 2 squared. Let me just use that already to evaluate y prime at 0, because that's the origin. I want to find the slope at the origin. In other words, I want to find the derivative when x equals 0. That's why I wrote y prime of 0. 1/2 all over root 1 minus, well, x over 2 squared. Evaluated 0 is just 0, so I just put the 0 there. Well, that's really 1/2. Let's put it all together. Y minus 0 equals m x minus 0. Well, that's just y equals 1/2 x. Out of the answer choices, you should be able to, convert from slope-intercept form, that's really y equals mx plus b, to standard form pretty quickly in your head. There you go. We got A.